In this lecture, we are going to talk about the collections framework overview. So first of all, what is a collection? A collection is a group of objects contained in a single object. The Java collections framework is a set of interfaces, classes, and algorithms for storing collections. Some of the benefits are reduced development effort by using a core collection classes rather than implementing our own collection classes. So for example, if you want to implement a tree-like structure, a red-black tree, or a hash table, of course it is much more convenient to use Java collections framework related classes than implementing your own from scratch. Then code quality is enhanced with the use of well-tested collections framework classes. So we can take it for granted that these abstract data types and data structures are working fine and as efficiently as possible. Then reusability and interoperability are very crucial features of the Java collections framework. So the Java collections framework includes four main types of data structures: lists, sets, queues, and maps. The collection interface is the parent interface of list, queue, and set. So as you can see, collection is the parent interface of these ones. What's crucial that the map interface doesn't extend collection. So as you can see, the map itself is not a collection. Although maps are not collections in the proper use of the term, but they are fully integrated with collections, and this is why it is considered part of the Java collections framework. So this is crucial that there are four extremely important interfaces and three of them extends the collection interface. Okay, so lists, queues, sets, and maps. A list is an ordered collection of items that allows duplicate entries. Elements in a list can be accessed by an integer index. What is a queue? A queue is a collection that orders its elements in a specific order for processing. What is a set? A set is a collection that doesn't allow duplicate entries. As you can see, a list can have several entries with the same value. It is not true for sets. And a map finally is a collection that maps keys to values. So here we have key value pairs with no duplicate keys allowed. The items in a map are key value pairs. Okay, so this is the exact collection framework related hierarchy. We have the iterable interface as the parent class of collection. Lists, queues, and sets are extending the collection interface. This is what we have been talking about, that the map is not a collection. But as you can see, there are several lists, for example, an array list, linked list, vector, stack. There are several queues such as PriorityQueue, the queue, ArrayDeque. There are several sets: HashSet, LinkedHashSet, the sorted set, and the TreeSet, and there are several options when we want to use the map. For example, we can use a sorted map or a TreeMap. We can use HashMaps, LinkedHashMaps, and hash tables. The red ones are interfaces and all the others are classes. And as you can see, the dashed line refers to implementation, and the arrows when the given interface is extending another interface. Okay, what's crucial that we have the so-called iterable interface. When collection framework was created, it gave a powerful ability to acquire data from collections automatically. This is called iterability. So the ability to iterate through the collections one by one, and this is why it is needed to extend the iterable interface to the collection interface. So as you can see, the parent of collection is the iterable interface. Because of this iterable interface, we can use an iterator method or a for each loop to any kind of collections. So this is how we can iterate through a list, a queue, a set, which is quite a powerful feature. The iteration can only be applied to one-dimensional collections like lists, queues, and sets, but not to maps. You may pose the question why? Because iterator uses the indices of items and map doesn't support indices but key value pairs. So map can be iterated and hence can extend collection, which further extends iterable. So this is the reason why maps are not collections. Okay, let's talk about collection framework's useful methods. Another advantage of the collection interface that it contains useful methods for working with lists, sets, and queues. These methods can be familiar because we already talked about these in the previous lectures. What's very good that they can be used not only for array lists but also for other data structures or abstract data types such as lists, sets, and queues. These methods are the odd method, remove method, isEmpty and size method, clear method, contains method. With the help of the odd method, we can insert a new item to the data structure. With the help of the remove method, we can remove a given item from the data structure. With the help of the isEmpty method, we can check whether the data structure is empty or not. The size is going to return the number of items in the data structure. The clear method provides an easy way to discard all items in the collection. And the contains method is going to check if a certain value is present in the collection or not. Let's talk about collection versus collections. Before we look at the different collection classes in practice, here is an interesting but also confusing, tricky interview question about the collection framework. So what's the difference between collection and collections? The main difference is that collection is a root level interface. This is what we have been talking about. Most of the classes in Java collection framework inherit this interface. This is what we have been talking about when considering collection framework related hierarchy, that as you can see, collection is an interface and most of the classes of the collections framework are inheriting this collection interface. As far as collections is concerned, it is a utility class in java.util package which contains only static methods which are used to operate on objects of type collection. So for example, when we try to sort an array list, then we can use collections.sort, which is a static method within the java.util package, and this collections utility class has some extremely important methods. So this is what we are going to talk about in the coming lectures. Thanks for watching. In this lecture, we are going to talk about the concrete implementation of array lists and linked lists. So first of all, what is the crucial differences between array list and linked list? First of all, array list acts as a list while linked list acts as a list and a queue. So array list use dynamic array in order to store the items, while linked list use doubly linked list to store the items. As far as manipulation is concerned, array list is slow because if any item is removed from the array, all the bits are shifted in memory. It is crucial. So this is why array list is slower if we have to remove several items. While on the other hand, linked lists are faster because it uses a doubly linked list, so no bit shifting is required in memory. We just have to update the references. I'm not sure whether you are familiar with the concrete data structure of array and linked list, but linked lists are basically nodes linked together by references. So whenever we remove a given internal node, we just have to update the references, and this is why linked lists are extremely fast as far as manipulation is concerned. So whenever we insert or remove a given item, array lists are better for storing and accessing items, and linked lists are better for manipulating data. Of course, array lists are faster because it uses a simple one-dimensional array, and the most important features of arrays is that we can use indices. This is called random indexing. So if we know the index of a given item in a one-dimensional array we would like to access, then we can do it in order 1 constant time complexity, which means that array lists are faster in this case than linked lists. So both array lists and linked lists have several advantages and disadvantages as well. Anyways, let's take a look how we can instantiate an array list. We can do something like this. List is an interface, and because array list is a list, we can do something like this. We would like to store strings, so the array list is equals to a new array list. We can do approximately the same with linked lists. So because linked list implements the list interface, this is why we can do something like this. It is a good programming practice to program to an interface and not the implementation itself. Linked list is the class itself. list is the interface. So this is how we can achieve abstraction. Anyways, we can use the same methods in order to add items. So as you can see, ArrayList.add, it means that we would like to add Kevin, Joe, and Peter to the array list. We can do the same with LinkedList. We add Kate, Judy, and Julia. With the help of the iterator, we are able to consider every item of the data structure on a one-by-one basis. This is what we have been talking about, that as far as collection framework hierarchy is concerned, both ArrayLists and LinkedLists implement the list interface. The superclass is a collection, which superclass is an iterable, and because of the iterable interface, we can iterate through a list, a queue, and a set. So this is why we can get the iterator, and with the help of the iterator, we can consider all the items of the array list. We can do it with the help of a simple for loop, as you can see. So either we use the iterator, I guess it is a bit more complex to use iterators than using a for loop. I guess it is very simple. We use the LinkedList, and because it implements the iterable interface, this is why we can use a simple for loop. As you can see, we have to make sure that the types are matching. So because the LinkedList stores strings, this is why we have to use string here. And this is how we can iterate through with iterator, and we can iterate through with the help of a simple for each loop. So if we run the algorithm, the array list items are Kevin, Joe, and Peter, of course, because we have inserted these. The linked list items are Kate, Judy, and Julia. So as you can see, the array list items are printed out because of the iterator, and the linked list items are printed out because of this for loop. So this is how we can use array list and linked list. Both of these data structures are extremely important and extremely crucial. We use array lists whenever we would like to store and access data. So for example, when we have a database and we don't want to update the database, so we don't want to remove or insert new items. Whenever we would like to manipulate the data frequently, so we would like to remove and insert or update given items, then using linked lists is the best option possible. Thanks for watching. In this lecture, we are going to talk about queues and priority queues. So you can use a queue when items are added and removed in a specific order. Queues are typically used for sorting items prior to processing them. The Java queue interface orders the element in FIFO, so first in, first out manner. In FIFO, first element is removed first and last element is removed last. By the way, this queue is an abstract data type, and linked list, for example, implements the queue interface. For example, when you implement breadth first search, then we need a queue abstract data type, and this is why queues are extremely crucial. Breadth first search is a very important graph related algorithm. What about priority queues? The priority queue class provides the facility of using a queue, but it doesn't order the elements in a FIFO manner. The elements of the priority queue are ordered according to their natural ordering defined by the comparable interface. So basically, with the help of a priority queue, we can define the priority itself. There are several methods such as add, such as remove, such as pull and peek. So the add method is going to add a given item to the queue. The remove method is going to remove a given item from the queue. The peek method retrieves but doesn't remove the head of the queue. And the pull method retrieves and removes the head of the queue. So this is the main difference between peek and pull. So let's see a concrete example. I'm going to create a new class, for example, access card. And every single access card is going to have a string name, and they have an integer ID. So let's create the constructor. So source, generate getters and setters first of all for the ID and the name, and let's create the constructor as well. So source and generate constructor using fields. Okay, this is how we can define the name and the ID. And finally, I would like to define the toString method. So let's override the toString method. and here we just have to return this dot name plus some spacing and this dot ID. So every single access card has a name and an integer ID, and we can use a priority queue. And because a priority queue implements the queue interface, we can do something like this. First of all, we have to import java.util.queue, and we can use access card. Okay, it's going to be the queue, and it's going to be a new priority queue. So the main problem is that if we try to add a new access card, let's try to do so with name, for example, card1, and the ID is going to be 5 whatever. In this case, Java is not going to know that what's going to be the priority of the access cards. So this is why we have to make sure that this class implements the comparable interface, and we are going to compare two access cards. So in order to be able to compare two access cards, this is why we have to override the compare_to method. This compare_to method is extremely crucial to be able to compare objects of access cards. So of course it is a valid question that how to compare access cards based on the name or based on the ID or something like this. So that's why we are going to return with integer compare, and we can compare the IDs. So this dot ID and the other access card get ID. So this is how Java and the priority queue is able to compare access cards. In this case, we can add several access cards, the second one and the third one, and if we have the ID 3, then ID 7, then we can do something like, I would like to print out the queue.poll. The poll method is going to retrieve and remove the head of the queue, and this is why it is crucial to define the comparable interface, because what's going to be the first item, what's going to be the head of the queue abstract data type. In this case, because the access card compare_to method is going to define integer comparison, that's why the first item we remove from the priority queue is going to be the access card with the lowest ID value. So that's why the result is going to be 3. If we call this poll method 2 more times, then 5 is going to be the next one and 7 is going to be the last one, because basically we make sure that the priority is going to be the value of the ID itself. Of course, we can change it if we want to make sure that the highest value is going to be the most important item, so the first item of the priority queue. We just have to use -1. Of course, if we use something like this, then the first item will be the access card with ID 7, then with ID 5, and finally with ID 3. Of course, we can define this compare_to method however we want. For example, we would like to make sure that the access card priority has something to do with the alphabetical order of the name parameter. So this.name.compare_to o.getName. What does it mean exactly? That in this case, the first item, so the item with the highest priority, is going to be, okay, just to make sure it's going to work fine, let's give another name, for example, Adam, for example, Joe, for example, Kevin. In this case, the Adam is going to be the first item because Adam is the first item as far as the alphabetical order is concerned. Then Joe and Kevin, okay, let's shuffle the order to make sure that it's going to be the same. So if we save it and run it, as you can see, the Adam is going to be the first item because this is how we define the comparable interface compare_to method. The priority has something to do with the name, and this is why we compare the name parameters, which are strings. Okay, So of course we can use something like this. If we use the minus sign, in this case the first item is going to be the last item as far as the alphabetical order is concerned. So priority queues are extremely important. For example, shortest path algorithms such as Dijkstra's algorithm rely heavily on this data structure. So it is extremely crucial to have priority queues. It is a very important and extremely powerful data structure. We are able to use priorities, hence the name priority queue. Thanks for watching. In this lecture, we are going to talk about the ArrayDeque data structure. ArrayDeque in Java provides a way to apply a resizable array in addition to the implementation of the deque interface. It is also known as array double-ended queue or ArrayDeque. This is a special kind of array that grows and allows users to add or remove items from both sides of the queue. What's crucial that it is not thread safe, so if you have a multi-threaded application where several threads can manipulate and update the given ArrayDeque data structure, of course ArrayDeque is not a good option because it is not thread safe. There are several methods such as add, offer, remove, peek and poll. These methods are the same as we have discussed with PriorityQueue. What's crucial that here we have several additional methods: add first, add last, remove first and remove last, which means that we are able to manipulate both sides of the array. The add first method inserts particular item at the beginning of the deque. Add last is going to insert a particular item at the end of the deque. The remove first method returns the first item and also removes it. The remove last returns the last item and also removes it. So these are the most important methods as far as ArrayDeque data structure is concerned. So let's take a look at a concrete example. We have the deque interface. We are going to store integers, so it's going to be the deque is a new ArrayDeque. Sorry for that, of course, integer as the wrapper class. And here we can use several methods. For example, as you can see, we have the add method that's going to add the given integers. So in this case, just for demonstration purposes, let's add 1, 2, and 3. Then because deque is an iterable, this is why we are able to use a for each loop integer number in the deque, and we are able to print out the value. So we are able to print out the number. So this add method is going to add the values one by one, 1, 2, and 3. This is why we can use, for example, the deque.offer first. This offer first is going to insert a specific item at the front of the deque. So if we use this, then we are able to insert 0, and then we are able to insert -1 as well. So in this case, if we run the application, then first of all we have 1, 2, 3, but because of the offer first method, we are able to insert 0 and -1 at the beginning of the deque. Of course, we are able to do the same. So the deque, we have the offer last. In this case, it is going to insert the item to the end of the deque. So if we run the application, as you can see, 4 is going to be the last item. Another important method is the remove first and remove last. So we have the deque remove last. If we call this remove last method, then the last item is going to be removed, which is the 4. So as you can see, 4 is not present here. We are able to remove the first item. So if we remove the first item, then -1 is the first item, so it's going to be removed. As you can see, it is working quite fine. This is how we use the built-in methods of ArrayDeque data structure. Thanks for watching. In this lecture, we are going to talk about HashSets, LinkedHashSets, and TreeSets. So you use a set when you don't want to allow duplicate entries. So this is the main motivation behind set. We don't want to allow duplicate entries. Both of the sets are not synchronized, so it is crucial that if you use a multi-threaded application and you want to manipulate the same data structures, HashSet, LinkedHashSet or TreeSet, then you have to make sure that you use some synchronization because these data structures are not synchronized by default. There are several standard methods such as adding a given item, removing a given item, checking whether a given item is present in the data structure or not. What's crucial that a hash set uses a hash table as an underlying data structure. So a hash set stores its items in a hash table, which means that it uses the hashcode method of the object to retrieve them more efficiently. Hash set is the most commonly used data structure as far as sets are concerned. A linked hash set is used when you want to store items by the insertion order, and the TreeSet stores the items in its sorted order. Basically, the TreeSet uses a red-black tree as an underlying data structure that has quite favorable running time complexity, and it supports the sorting operation, which means that TreeSet is a sorted tree-like data structure. Okay, but because of the sorted order, TreeSet is slower than a hash set. So let's take a look at a concrete example. Because all of these data structures implements the set interface, we can use something like this. I would like to use integers, so integer hash set is equals to a new hash set. This is what we have been talking about, that a hash set relies heavily on a hash table under the hood. Okay, let's import java.util.set. And we are able to add given items. So I would like to add the integer 10. Then I would like to add, for example, 20, 30, and 40. We can check whether the hash set contains a given item or not. So HashSet.contains the value 10. Of course, we should get a true because 10 is present in the data structure. But for example, 100 is not present, so this is why we get a false. Of course, we can remove a given item. So if we use something like HashSet.remove and we specify the item, we are able to remove the value 10. Because the set interface is a collection and the collection is an iterable interface, this is why we are able to use a for each loop and iterate through all the numbers. So we can use something like this and we can print out the number. So if we iterate through all the values, as you can see, HashSet doesn't maintain any order. 20, then 40, then 30. So it has nothing to do with the order in which we inserted the given items. So this is why HashSet is not going to maintain the insertion order. Okay, so let's try to use a LinkedHashSet instead of a HashSet. So if we use a LinkedHashSet, we have to import java.util.LinkedHashSet. If we use a LinkedHashSet, then if we consider the items one by one, then it is going to be the order in which we have inserted the given item. So in this case, 10, 20, 30, and 40 is going to be the order, which means that a LinkedHashSet maintains the order in which we insert the given items. The problem with LinkedHashSet is that we are not able to get the sorted order. So if we insert, for example, 100, then 22, then 3, then 40, I'm going to insert some further items, 51, then 29, and we would like to end up with the sorted order. We are not able to do it with the help of HashSet and LinkedHashSet. And this is why if we use a TreeSet, then it is going to make sure that the items we insert are going to be in a sorted order. Okay, so let's import it, and if we iterate through the items, as you can see, it is the numerical order, which means that 3, 22, 29, 40, 51, and 100 TreeSet maintains a natural order as far as the items are concerned. But because a TreeSet is way slower than a HashSet, a good approach is to use a simple HashSet. And whenever we would like to end up with the sorted order, then we can create a set integer sorted set is a new TreeSet, and here in the constructor we can specify the HashSet, and Java is going to generate a TreeSet based on the HashSet items. And if we iterate through the sorted set, then again it's going to be the sorted order. So it is a bit better approach because a HashSet is way faster than a TreeSet. If we are after the sorted order, then we can transform a HashSet into a TreeSet, and if we iterate through all the values, then it is going to result in the natural ordering. So this is how we can use HashSet, LinkedHashSet, and TreeSet. Thanks for watching. In this lecture, we are going to talk about hash maps, hash tables, linked hash maps, and tree maps. So a map can store pairs of key values. So each key is linked to a specific value. Once stored in a map, you can later look up the value using the key exclusively. So basically, with the help of a given hash function, we are able to transform keys into array indices because maps are using a one-dimensional array as an underlying data structure. And with the help of the hash function, the keys are transformed into array indices, and the given array index is going to store the value itself. So every key is associated with a given value. This is why a map is able to store key value pairs. A hash map doesn't allow duplicate keys but allow duplicate values. HashMap is not thread safe. On the other hand, a hash table is thread safe. This is why hash tables are slower than hash maps. So the most popular data structure as far as maps are concerned is HashMap. Okay, it is not synchronized, but it is quite fast. It uses less memory, and this is why usually it is the best option possible. A linked hash map preserves the insertion order. So again, hash table and hash map is not going to preserve the insertion order. A linked hash map, on the other hand, does. And TreeMap stores the keys in a sorted tree structure. Again, TreeMap uses a red-black tree as an underlying data structure that has quite good running time complexity as far as the operations are concerned. The main benefit is that the keys are always in sorted order. There are several important methods. With the help of the put method, we are able to insert a given value associated with a given key. With the help of the get method, we are able to get a value based on a given key. The size is going to return the number of items in the data structure. The clear method is going to remove all key value pairs. The entry set is going to return a set that contains the entries in the map. So let's take a look at a concrete example. Because all of them implements the map interface, we are able to program to an interface. In this case, we will use integers as keys and we will use strings as values. This is what we have been talking about, that a map stores pairs of keys and values. Keys are integers, values are strings. In this case, the map, and it's going to be a new hash map. Okay, so we have to import java.util.map. And we are able to insert, with the help of the put method, a given ID as the key and given value. The value is going to be the name, the key is going to be an ID. So let's insert these values: Adam, Joe, Tom, Adam, Kate, and Judy. This is what we have been talking about, that with the help of a hash map, it is possible to have duplicate values. What's not possible is to have items with the same key value. But as you can see, it is no problem to have the same value associated with different key values. So if we want to iterate through a map, we have to use map.entry, and we have to define that it's going to be an integer and string as the value. These are going to be the entries, so it is an entry. And we have to use the entry set. So this entry set is going to return a set, as you can see. So returns a set view of the mappings contained in this map. Okay, so let's get the entry set, and here we are able to print out the entry get key plus some spacing and the entry get value. So this entry stores the key and the value as well. So if we save and run it, as you can see, it is working fine, but the order is not maintained. So this is not the same order as we have inserted the given items. If we use a LinkedHashMap, then Java is going to maintain the order in which we have inserted the given items. So in this case, if we run it, as you can see, the first item is the first one we have inserted, then the second one, the third one, fourth one, and so on. So with the help of a LinkedHashMap, we are able to maintain the order. But again, how are we able to get the sorted order? So we would like to sort these values based on the key, so the first parameter. And this is why TreeHashMap is very powerful, because with the help of, sorry for that, TreeMap, not TreeHashMap, but TreeMap, this TreeMap is going to maintain a sorted order as far as the key values are concerned. So if we use something like this, as you can see, it is the sorted order as far as the key values are concerned. So 1, 10, 30, 90, and 155. Of course, if we insert a given item with a previously used key value, then the given entry is going to be updated. So as you can see here, we have Kate, but this has been updated to Judy, and this is why we have Judy associated with the integer 10. So this is how maps work. HashMap is quite fast, so this is the most commonly used data structure as far as maps are concerned. With the help of LinkedHashMap, we are able to preserve the insertion order, and with the help of the TreeMap, we are able to end up with the sorted order as far as the keys are concerned. Thanks for watching.